I'm Anil Kumar. Welcome to my series on complex numbers. In this video, we'll try to understand how to represent complex numbers in polar form, which we also say modulus argument form. So let's consider a variable complex number z, which could be written as x plus iy. Now you could always represent this on a coordinate plane with real numbers along the x-axis and imaginary numbers along the y-axis. Now when you represent on this plane, then we call this as an Argand diagram. So in Argand diagram, we have real numbers along the x-axis and imaginary along the y. So any point here could be represented. So if I write this as x, y now, so where x is the real part and y is the imaginary part, right? Now we could also relate it with the polar form. So in polar form, what we do normally is we consider r to be the magnitude of z. So r becomes the magnitude of z, which is the modulus. And theta is this angle which it makes with the positive x-axis, right? Or the real x-axis positive. So theta will be referred to as argument. Now the value of theta is taken from minus pi to plus pi. Now if you take this value from minus pi to plus pi, this is called principal argument. You know, you can always add 2 pi and get many values, but that makes it unique. That is the reason. So we normally work with principal argument, which is unique, and always in radians. So we work in radians. Perfect. Now, if you use calculator, we can find the value of theta using tan inverse ratio, correct? Now, let's try to understand how do we translate these things. Now, once again, let's consider this particular diagram. The Argand diagram, where we have the real axis and the imaginary axis. And we'll again consider the complex variable here with the value xy. So as you can see, if we drop a perpendicular along the x-axis, then this value here, taking the angle as theta, will be what? If I take r as the magnitude of the modulus, then from O to this value, the x component will be r cos theta, and the y component will be r sin theta. Therefore, the complex number z x plus iy can now be written as z equals to r cos theta plus I sin theta times r I sin theta. Okay. Taking r common, we get cos theta plus I sin theta. So that becomes the polar form. So in this form, r is equal to the magnitude part, which is x square plus y square square root, and theta is equal to tan inverse of y over x. Right? So that is what it is. However, this value tan inverse y over x will be seen in more details. So this is not always correct, right? So what we get here is we may have to do some adjustments depending on where the complex number lies, in which quadrant. So if you use calculator normally, then in quadrant 1 and in quadrant 4 we get the correct values. However, if you are in quadrant 2 or in quadrant 3, you may not get incorrect values. So you need to do adjustment for quadrant 2 and quadrant 3. I will tell you the reason why. Okay, so let's once again construct this Argand diagram. Now here, if I have, let us say, my complex number in quadrant 2, let me take a concrete example. Let us say we have z equals 2. So here we have negative, let's take negative 1, and positive value for I, let's say. Okay, so let this be the complex number. So clearly the magnitude r will be equals to 1 square plus 1 square, which is square root of 2. However, if you calculate theta, you will get tan inverse of minus 1, right? So tan inverse of minus 1, if you calculate, shift, this should be in radians, tan inverse of minus 1, what do you get? You get minus pi by 4. Now minus pi by 4 is not correct. Minus pi by 4 means you are trying to write this. This is minus pi by 4. But the actual answer, as you can see, is not that. It is this. Since you are in quadrant 2. Therefore, this angle theta should be corrected. So this is, you have to add pi in this case, correct? To get the right value. Right? So the answer should be minus pi by 4 plus pi. That is 3 pi by 4. Correct? And with that correction in mind, you get your complex number z as magnitude square root 2, right? Cos of 3 pi by 4 plus I sine of 3 pi by 4. Is that correct? So the adjustment has to be made. So I hope this concept is clear. Let's take this concept once again on a fresh page. So what we're trying to say here is that if you are considering, let us say, a complex number in this part, correct? Just as we took the example, let's say z, which we took was minus 1 plus I. So here, when you calculated the angle, what did you get? The argument which you calculated, you got this value, which was minus pi by 4, right? For the actual value, you had to add pi, right? So that you get the real value, right? So you have to add pi to get the actual argument, which was 3 pi by 4. Do you see that? So if you have the complex number in quadrant 2, in that case, the argument is going to be equal to tan inverse of y by x plus pi. Is that clear to you? Right? Now, let's take an example where the complex number lies in quadrant 3. So quadrant 3 means, we'll keep this as negative. Okay, it's negative. Let's say negative. Let's make it square root 3. Okay. And this value also is negative I. Let's take it 1, right? So we'll just take I. Okay. So if that is the case, we could actually use a special triangle also to find this answer. So in that case, if we again work out, then r will be equal to square root of this square plus this square, which is 3 plus 1, which is square root of 4, that gives you 2. As far as theta is concerned, when you calculate, you will get tan inverse of minus 1 over square root 3 with a negative sign, both positive, right? So if you do that, which is same as tan inverse of 1 over square root 3 with the calculator, what do you get? Shift tan inverse of 1 divided by square root of 3 gives you pi by 6. So you get theta equals to pi by 6. Clearly, theta equals to pi by 6 is incorrect. When you say pi by 6, you're trying to write the answer to be here, right? This is pi by 6. However, minus square root 3 minus I happens to be right there. So what should be the angle? Theta is not pi by 6. So theta basically is equal to pi by 6 minus pi, since this is your angle. Correct? Not that. So from pi by 6, when you take away pi, you get your actual angle, which is this. Right? So when you are in quadrant 3, then the argument will be tan inverse y by x minus pi. Now that's a very important thing to remember, right? So when you do that correction, then you get pi minus 6 pi by 6. So you get theta equals to minus 5 pi by 6. And therefore, this complex number could be written as r being 2 for us, cos of minus 5 pi by 6 plus I sine of minus 5 pi by 6. Is that clear to you? So that becomes the right answer, right? So it is important to note that the adjustment should be done in the argument theta whenever you calculate the argument, right? So to cut short, note, remember to adjust argument if z is in quadrant 2 or quadrant 3. So with that note, I think you understand completely how to write a complex number in modulus argument form. So we'll follow up with few examples and a test question to give you a complete overview picture of this topic, and I hope that will surely help. Feel free to write a comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.